Good evening, everybody. Let us start our lecture tonight. And sorry for the bad weather. Let us see if we can wrap up early tonight. And according to our schedule, you will have your test 3 on next Thursday, like this time, right? Next week, this time, right? Okay. I will try my best to come on time, and then we will start our test on time. But in case I am late, please wait for a few minutes, and we will start. We will have 45 minutes for the test time. Okay. So I think we will have enough time. I already passed a study guide on D2L. Please follow the study guide, and if you need it, then follow my recorded lecture videos. And again, I'm telling you, test will be a little bit different than previous test. So you really need to study and practice in order to do well in this test. Okay, so we were discussing file I/O operations. So I believe I went through all of these basic rules of file I/O operations. Okay, there is now nothing much to discuss, but I like you to practice. When you practice, then you will find something new, and then there are a lot of resources in your book and then online. If there is something that I missed in my lecture, then you can find it online or in book or and many other places. Okay, so I discussed with some sample programs with Java. Sorry, I got a new laptop. I do not have Visual Studio installed on this laptop, so I wish I could demo Visual with C++ file I/O operation. Why is not coming up? Okay. So in our last program, in our last lecture, I discussed how to create a data file, how to write on the data file, and how to read from the data file. I discussed only with Java program on that day, and with Eclipse. Okay, but if you practice with Eclipse, that will be great, because most companies they use Eclipse or NetBeans. Okay, but I tried and I checked that it also works for Replit. It also works for Replit, and with Java okay. I tested some programs that it works with Replit for Java. So why there is a user bar? Okay, the issue comes from PowerPoint maybe. So this is a small, very tiny Java program. Then it will do what it will do. If I run this program, it will create a text file by my name mokhtar.txt. But if we want to give a different name, like test.txt. Okay. So you see that on the left side here on the bar, you see that this file will be created here on this location by default in with Replit. So if I give this name test.txt, so you see that it created this file test.txt, and there is nothing on it since we did not put any data on it. Okay, so this is the another program that we discussed in our last lecture. So this program, if we run this program, it will create a data file myfile.txt, and whatever you type in on the data file, that will be saved on that data file. So I tested and I found that these work on Replit. So you can practice on Replit as well as on, sorry, but if I print something, so then as soon as I press enter, then it will show me. So now I have a quick question to you. What do I need to do if I want to enter multiple lines? And for instance, you see that in some program it says press Ctrl plus F or Ctrl plus F4 or Ctrl plus Q to quit. Okay, for instance, here actually the code that I said while C means character not equal to is this \n within single quote, that means it is a carrier's return, that means \n. Okay, so even you can put without, since C is character type, you can put the ASCII value for the \n. \n is it 32? ASCII chart 32? Maybe 32. ASCII table for the carrier's return. Okay. You see, for instance, if it says Ctrl plus F or something, so acknowledgement or something that has value 6, decimal 6. So if 6, 32 space, what is the carrier's return? CR. Okay, carrier's feed. Okay, line feed, next horizontal tab. So even we can use some of this instead of this. We can use this ASCII value, character value in here. For instance, in this line. For instance, if I put K, okay, what is the ASCII value of A is in uppercase? 65, right? 65 is A is in uppercase. So until I fresh in uppercase A, then it will take my data. Oh, sorry, I changed over here. Sorry, my program. So if I want to make it A, I can put A like this way, either with single quote, or even I can put ASCII value of A, 65, then press A. Okay, so in this case, I can use multiple lines. So if I type in and then if I even press enter, it will not be terminated because it is asking for uppercase A, right? So even I press lowercase a, it will take lowercase a. As soon as I press uppercase A, then whatever I print, okay. So actually it will take before uppercase A. It will take until before uppercase A. So then until it gets uppercase A is in 65, right? It will take those values, not after this, including A. It will not take this. So you can modify your program and try and run this. So let us try something with C#. So my GitHub account has C# package. I discussed, right? I told you, I showed you. What is my GitHub? CSE1322 review C#. So this is the package C# with file read all text file. Okay, so there are three programs here: file read, file write, and read and write together. So let us see if this work, one of these work. So my program is over here. Okay, let me create a new replit program, C#, file read example1 C#. I did not try. This is the first time I'm working on C# with replit for file operation. I'm not sure that it will work, but let us see. So we need this, right? Okay, so we need this part until including main. So we need this part with the main, and I also need this. I need to use this IO. Also maybe collection. Try this. Okay, I do have system already, so I don't need this one. Okay, let me see if it works. So if it works, then it should create a file test.txt on the left side. Okay, no, it did not create test file. It says the file does not exist. Okay, let me try another one more. Example 1, read write. So read write. 39. Maybe there is an extra. Okay, there is an extra. Okay, this is working. Maybe there is a problem in the. Okay, I see. I got it. I know what is the problem. So test.txt. What is that? Previously it was TT. Okay, by the way, it is working. It works that it's created the text file test.txt, and on the file just I wrote some numbers. You can write randomly generated text on your data file, or you can type in, or you can use I just here use a for loop, or you can use a random method to randomly generate some numbers, and you can put over there. And okay, this is working something. Okay, so C# people, please practice this. Okay, so I have more programs over here. I have another programs here on this project file write all. Okay, I know my mistake. I was supposed to run this write program first in order to create the data file, right? And then I was supposed to open that one. My mistake. Let me try this one. Right. Okay, that is my write program. Okay, this is the sticks thing I need. Write program. I need this into my main method, and I'm sorry, and I will select this part. Okay, let us see if it can create a data file named test.txt on this folder. Okay, please enter a new contents of the file. Oh, okay, it creates data file. Okay, and let me see. Okay, and it creates and takes until I press enter. Whatever I put over there, it takes that value. Okay, so please practice this. Please practice this. I have nothing more to discuss for file input output operation. This is your task, and you need to practice. And just what I need for the test, you will not be asked to write an entire code to do read write operation for a data file, but you may be asked some simple questions of like some function of some methods. For instance, what methods we should use, need to use in order to write operation or read operation, or just basic format. Not, you don't need to memorize the entire code. Okay, so but I like you to practice this code and keep in your account. So wherever you go, then whenever you work, then you can get your copy, get your code from your account. Okay, so let's see what is next we do have in our. By the way, next test will be test 3 will be on next week this time, right? Anyone has any question about test 3? Okay, that's good. So okay, so next week we will use one lecture for discussing for our test 3. So I will miss a lecture. So let us spend about maybe 30-40 minutes to discuss about threads and parallel processing today. A few minutes so that we can cover it, we can finish it in our one lecture in our next week. So threads. Okay, threads is a program execution path, like a lane on a roadway. Okay, a program can have multiple threads, like a road or a highway can have multiple lanes. So if we have multiple lanes, parallel lanes, then what we can do, one of the benefit or advantages is that we can have multiple vehicles can drive parallelly, right, through multiple lanes. So similarly, if we have multiple threads or multiple execution path in our programs, then we can run multiple programs parallelly or simultaneously using a single processor. Okay, so what are the programs so far we discussed were only single threaded program. So in a single threaded program we had a main method, and the main method runs on the main thread. That was the main thread, only one thread we had in our program. So for whatever programs we discussed, only single threaded. So then it is possible to create multiple threads, more than one thread, to run multiple either programs or multiple methods or multiple processes simultaneously or parallelly. Okay, so like most modern programs, okay, nowadays are written in multi-threading options. Many programs, the web-based programs. Okay, since like due to have huge amount of data or like people expectation that more people will be able to handle a website parallelly. Like think about the situation on a certain day like Black Friday time. How many people log into a website to get a deal? Like maybe more than 10 times or 5 times people that are generally they log into a system, maybe it's Amazon website. Other day, then they maybe 10 times more people they try to log in on Amazon. I have an experience a few years ago. I bought a laptop on deal, okay, on the Black Friday, midnight. It took me about an hour to make the payment. So the line was maybe slow, but it did not disconnect me. It was showing me, wait, we are processing. Maybe a lot of people logged into the system. Okay. So in that case, what we do expect? We expect that our program will be executed faster. Okay. So then what we can do? We can use, okay, multiple threads. Okay. So another concept is that we can use multiple threads concept is parallel processing. Okay. Nowadays another thing is that due to like improvement of hardware in addition to software, you will see that most computers have multiple processors. Like there are some processors, sometimes 2 or 3 processors that are called co-processors. So some of the co-processors are used for certain tasks, maybe mathematical operation or something. If you think about like a matrix operation, that takes more time. Or for instance, a large multiplication or division operation, it takes longer time than an addition operation. Okay, but if the addition operation is for adding some integers, even some integers, we need to align the numbers, single digit to single digit, right? 10 digit to 10 digit, and then we can do arithmetic operations. And if that situation is more complicated when there are decimal points. Okay, so this is why those operations takes more time. Those operations take more time. So modern computers are being developed with multiple processors. So multiple processors can be used parallelly to execute parallel processing. So in our next lecture, topic we will discuss parallel processing, but today we will discuss threading, multiple threading. Okay, this multiple thread are the base of parallel processing. So once we understand multiple threading, for instance, what will we do in this lecture? We will learn how to create thread. Okay, and how can we separate our works, separate our tasks? We can send some tasks to one thread and other tasks to another thread. Okay, especially this happens for large program, but we may not be doing too much large program here, but we can do some test programs. Okay, and define some worker function or method. Okay, so I will discuss about this soon. And create threads that tell which method to run when it started. Okay, and then run or start a thread. So mainly we need to learn how to create a thread. Okay, so a program with multiple threads is called multi-threading programs. Okay, so this is the some introductory information about multi-threading. So multi-thread application delivers the potent power by running many threads concurrently within a single program. So this is the word I want to highlight, so that we can remember. So we will run multiple threads over a single program. That is the concept of multi-threading. Okay, only one program we will use, but in our one single program we will have multiple threads. But so far the simple program we discussed, those are only single threaded, the main thread, that is called the main thread. Okay, so the structure of a multi-threaded program is like this. Okay, there will be a main thread that contains the main method. Okay, and main method when it can start multiple threads, so like thread A, thread B, or thread C. Okay, and your program control can switch from one thread to another thread. So even the compilers are being updated with for multi-threads and parallel processing. One of the things that we will discuss about that is called fork join pool. That is a good concept how to execute a larger operation faster. So this is the structure for a multi-thread program. So let us see what I can say. Okay, there are two ways to create a thread. First of all, we need to know how to create a thread. Okay, there are two ways to create a thread. Okay, number one, I'm talking about Java for now. Okay, number one, by threading the thread class. In Java has a thread class, built-in thread class. If we extend the thread class, if we create a class that extends the thread class, then we can create a thread. Or Java has a runnable interface. So if we implement that runnable interface, then we can create a thread class. In our thread class, we can implement the runnable interface. So let us see the first technique, how to create a thread. So the first technique is to just extend the thread class. Okay, in Java, just extend the thread class. This is my thread name. This define a class like my thread, and this is just this part we need to do. We need to extend the thread class. Okay, thread class is a built-in class. Okay, once we extend the thread class has a an abstract method, run method. We need to override the run method. So we know that if we extend an abstract class, we need to override or rewrite the abstract methods in it, right? Okay, so the run method is the abstract method that is an abstract method that is defined in the thread class. So we need to override the run method. So it's up to you or up to us or the program. It depends on the programmer how do we override this method. For our simple program, we will write maybe a print statement within the run method. Okay, then so I have my main thread. Okay, I already have a thread, main thread, that goes under, that is default thread under my main that contains my main method, and just I am creating another new thread. So how many threads I do have? So far 2 threads, right? So this is a simple multi-threaded program. We can consider that with at least 2 threads. Okay, so then in my main method, what I can do, I can create a thread object for this thread, my thread class. Just creating a thread object is simple, right? Everybody knows this. Simple as this. Okay, then I will call the run method. But interesting thing is that we do not call the run method explicitly. We call, there is another method that is called start method. Start method calls the run method. So we are calling the run method indirectly. Okay, so this is a thing that if you need to remember that although we override the run method, but we do not call the run method directly. We call the start method. The start method calls the run method. Okay, so this is as simple. Maybe this is a very simple. Okay, very simple multi-threaded program with at least 2 threads in it, right? So I can have another thread. I can have another thread. I can create my thread 1, my thread 2, my thread 3, as many threads I need. So in my program, for a large program, what is being done actually? So there are multiple threads are created and multiple so run method runs. Multiple run methods run parallelly or simultaneously. One of the thing maybe I can, what is the good example that I can show? Because these are not this simple. This is the startup. Okay, so what? Okay, so when we open our Google Chrome or any web browser, sometimes we frequently pressed Command or Control plus T, right, to get a new tab, right? So our new tab, okay, runs under, okay, so under the Chrome browser, right? So if my browser is not open, a new tab will not open. So my new tab works under my Chrome browser. So consider that, we can consider that each of the new tab is a thread. So whatever we can do maybe similar operation for each of the threads, right? each of the tab. So maybe we can browse multiple operations, or we can run multiple programs, web-based programs on multiple tab parallelly. So that might be an example of multi-threading or parallel processing application. Okay. So let's see. Then I will go to my program. Okay, so I will go to another program to discuss this. Okay, so there is another way to create a thread just by implementing the runnable interface. Since runnable is an interface, so we need to implement it, right? Instead of extend keyword, we will use implements keyword. Okay, so the runnable interface still it has the run method. Since an interface is 100% abstract, right? So we need to override the run method. So whatever I want to do, however I want to do, I can override my run method right here. And then similarly, I can create object. Okay, I can create object, but this time there is a different strategy. Okay, so you see that when I used thread class, when I extended a thread class, it was very simple to create a new thread object. But if we extend the runnable interface, the process is a little bit complicated. Okay, first of all, we will create an object for this my thread, like my object, and we will use this my object as an argument for the thread constructor for thread class. So we know that thread class is a built-in class, right? So for this process is a little bit complicated. We need an extra line for this. Okay, we need an extra line for this. And then we will pass this object here to my thread object, to the thread constructor, and then the remaining part is same. We will have this thread class, thread object, to call the start method, and the start method will call the run method. That's it. How many slides I do have? So these are the some program code snippet. This is not complete program, so this is Java. Let us see how many what are the slides I do have. So everything discuss about this. Okay, so thread life cycle. Okay, I will go to the live program shortly, but let us discuss, and there is another one more topic for this. It's called thread life cycle. Okay, different stages of a thread during its execution, program execution time. Okay, there are 5 or 6, maybe 5 different stages of a thread during its program execution, during its lifetime. Those are called. So the process, the entire process is called thread life cycle. Maybe I can. You see? Control A. Okay. So the first state is called newborn state, and then runnable state, running state, block state, and dead state. I think most of the names, these names of this state, okay, actually these refer to their functionality, pretty recognizable. So newborn thread is just a thread that has just born or created. Okay. So a newborn state can be done, can be started, or it can be killed. So the stop operation we use to say is a stop in order to stop in order to kill a thread. Okay. So whenever we have a newborn state, then if we send it to its thread pool, it's called thread pool. So active thread, this is the pool for active threads, thread pool. Then that becomes runnable state. That becomes a runnable state. So at the runnable state here, there are multiple threads that are being waiting. Actually, this is the thread pool, thread reservoir, where multiple threads wait on a line. So here at this point, a thread can be stopped, or a thread can be blocked or temporarily hold. Okay, or it can so it can run at this point. It can send for running. So at this point, after that, a thread becomes its running state. Okay, and if a thread is sent to in like what is called suspended. If a thread is suspended, sent to suspension, then you say call that is blocked, or if thread is blocked, then this is called block state if a thread is suspended. So a suspended thread can be resumed to run it, or it can be stopped. Then we can kill it. Can be killed. So the names actually the pretty straightforward and discuss methods. So there are some methods in Java in the thread class. Okay, so there are some methods in order to control the life cycle of thread. Like created, we already know how to create a thread. Then there are some methods to start a thread. Okay, then stop a thread or suspend a thread, kill a thread, or rerun a thread. Okay, so these are the methods, that common methods in Java. Okay, for instance, the get name method. This get name method retrieves the name of the running thread in the current context. Okay, it returns a string type. Okay, we already know that the start method. Okay, we will start a new thread of execution by calling the run method, right? Run method of thread or runnable object. So, and the run method, this method is an entry point of the thread. Okay, execution of the thread start from this method. So our program execution will start at the beginning of the run method. Okay, then there is a method called sleep. We can suspend a method for a certain time. The time is given in millisecond. Okay, and we can yield the yield method. By invoking this method, the current thread pause its execution temporarily and allow other threads to execute. So by using yield method, we can pause a thread and we can allow other thread to be executed. Okay, and when a thread is under suspension, we can use the join method to resume its execution. Okay, finally this method is alive, boolean is alive method. This method is used to check whether a method is alive, still alive or dead. So if a method is still alive, maybe it is running, either running or in suspension, then it returns a true value, otherwise it returns a false value. If that a thread is dead, that it returns a false value. Okay. So if we know like these operations, then we will be able to do some thread operations. Okay, and maybe if you take advanced level course, like for instance advanced level course for developing games, okay, that needs synchronization. Okay, maybe most of the games now work for synchronous mode, but there may be some asynchronous modes. So then you will learn more if you take advanced level course. You will learn more about thread synchronization. Okay, so there's some just idea about thread synchronization, some basic information, but there is not more. Okay, one of the things that, so when we go to our control panel, then in Windows, this is Windows, okay, we can see how many threads are running, how many threads or processes are running. The difference between a process and a program is a process may not be a complete program. Okay, a program is maybe a complete program in general, or a program can contain multiple processes. Okay, so whenever we go we do our control panel, then in Windows maybe we paste Control Alt Control Delete, right, to see the taskbar. You will be able to see this kind of. So you see another tab. There is another tab is called threads. So I don't have a Windows computer right now. Here, so if you go do this and you see the threads, you can guess how many threads are running. What are the threads are running? So these are the thread ID that being running at the beginning point of computer memory. We do not need to know these memories, but for the operating system handling purpose we need this. Okay, these are the slides that I do have, and in our next lecture I will see if I can bring some programs with C#. Let me see how. Let me see if I have some programs or with threading, multi-threading. So if I go to here, how can I make it larger? Command plus this side, how can I make it larger? Do you have multi-threading? Method overloading. Okay, maybe I don't have here. Now next lecture I will bring some programs and I will see. So do you see a parallel processing? Okay, let me see in my Replit. Okay, I have here managing threads. Okay, I have some programs with C#, how to manage threads. Thread start. Okay, I see one project. Maybe I have at least 2 projects for threading. Okay, there is another one, thread synchronization and multi-threading example 1. Okay, C# uses a little bit different strategy for threading operation, but I have some programs over here and the basic operations are almost same. So if it has start method that is used to call the run method, but you see start method is S is in uppercase here in C#. Okay, so if you are taking C#, please go to my project and practice this program. In our next lecture we will run some live program and we will see how we can do multi-threading programming. Okay, anyone has any question? So please be ready for the test, and if you cannot take the test, then your final exam will compensate that. But if you join in the test, your final exam will not be compensated, will not be used to compensate it. Okay, and thank you so much and drive safely.
What is the last topic covering test 3?
Test third?
Test, the third one. What is the last topic that you have to know for the third test?
Yeah, it says weeks 7 to 10. What is 10 weeks 10? Stack and QE.
Oh, I didn't see that. Alright, thank you. So pretty much for the refund credit for the test, like we're just continuing to submit what we've been working on and like showing that we've been practicing outside of the mandate.